Good morning, students. In the last session, we were discussing what the various service models which are available in cloud. Now, in today's session, we will discuss some concepts related to the security aspect of a computing system as a whole and how they are related to cloud security, and we'll see in the upcoming lectures. So basically, we can easily say that all the service models which we were discussing in the previous sessions, like SAA, SPAS, and IaaS as infrastructure as a service, all those service models, they are very much helpful for the end users or the customers. But the what one thing is clear, that is whether we take into consideration the concept of the service models, whether it is SaaS or PaaS or whatever. One thing is common. One thing is very much sure. That is, we are keeping our data. We are keeping our applications. We are being provided with some resources, but those things are not in our own disposal. We are taking help of some third parties. Some third party organizations are there. They are providing us with all the services. So basically we are being forced to keep our applications, our data to the to the resources which are not in our disposal. That means there are some issues related to the security of these things. That means whether the particular data which we are storing, is there anybody who is who can view those data, or is there any entity which is trying to break into the security of those data and try to fetch some informations from all those records, and all those things are there. That means for the successful evolution and implementation of a distributed computing like cloud computing, we have to take into account the concept of security in a very serious manner. That because if the system is not made secure, then the ultimate end users or or the consumers, mm, they will not be interested to uh, work in a particular environment. So coming to that part, we will start our discussion for today with three very basic components which are related to security. We call them CIA model. What is that? First is the confidentiality. Confidentiality means keeping our data and resources hidden from unauthorized access or from malicious users. That means in any case of security mechanism, that is our utmost important priority, to keep the data confidential in what manner it is possible. Next is integrity. Now, integrity may lead to data integrity or the origin integrity. That means data should not get modified in whatsoever manner. It must be kept intact in its proper format, and the origin or the source of the data communications pathway should not change. I mean to say that if someone is, say, if source A is sending some message to destination D, then destination D should get the message in the proper format which A sent to it, without any sort of modification, and destination D is also guaranteed to get the data or the message from source E only. And third one is availability. That means uh, we should have we should have a continuous access to our data and resources which are being kept in the premises of some third party organization. So basically, that is the CIA model, which is definitely applicable to any sort of security mechanism, say computer security or information security, and definitely those applies to cloud security as well, because cloud computing is nothing but an amalgamation of the previous technologies. It is not something new been developed overnight. So whatever technologies we are working in cloud, all are pre-existent, and we have to use them in the most efficient manner. Now, coming to the security attacks. So basically, it can be of 4 different types. So basically, any action that compromises with the security of the information can become as as a security attack. Now, there are 4 different types of attacks which can happen. Those are interruption, number one. So basically, interruption means some sort of attack on the availability of the resources. Here, resources can be physical resources or data or applications, whatever. Next is interception. Interception means attack on confidentiality. That means some intruder is there. That intruder is also sneaking into the communication system to get hold of some messages which are being transmitted at a particular point of time. The third one is modification. What is that? It is an attack on the integrity. That means, say, source S is sending some message to destination D. Now that that original message, uh, the original message is caught by an intruder, and the intruder modifies it and sends it to destination D. Here, the destination D is getting the feeling that the message is being transmitted from A, but actually it is a modified message being sent by the intruder, say I. That means someone has modified the message in between the communication pathway, and the source or the destination, they don't have any idea about the modified message. And last one is fabrication. Now, what is fabrication? That is a kind of attack on the authenticity. That means mm, suppose an intruder is there. Why? The intruder um, uh, the intruder pretends to be the originator of any message, but he will do, but it will do this thing with the help of some disguise of some other entity. That means uh, some sort of known entity. It will take the identification of some known entity to the destination of the, so the destination will get a message, but actually it is the intruder it is the intruder who will send the message to destination D here, but the destination D will assume that somebody else has uh, transferred the message to it. So that is the concept of fabrication. So basically, these are the 4 different types of attacks which we have to deal with in case of the security mechanism. Now, wait a minute. Okay. Now, what are the different classes of threats that we have, that generally we face? Number one is disclosure. Disclosure means what? Disclosure means somebody is uh, getting some sort of information which it should not get. That means by some unauthorized means, some intruder is there, it gains access to those messages. It can be done by snooping. Basically, what is snooping? It is an unauthorized access to another person's or company's data. Now, sophisticated snooping uses software programs to remotely monitor the activity on a computer or network device. Now, snooping basically can also be done by some organizations to check their clients' usage of the networks. Those things are there. It can be implemented in a good way also, but basically it can be used as a monitoring purpose. Now, the second is deception. Deception means modification, spoofing, and denial of service. So basically, what is spoofing? In the earlier one, we noticed the concept of snooping, and now it is spoofing. Spoofing is an act of disguising a communication from an unknown source as being from a known or trusted source. That is, it is some kind of deception which is being carried out. The intruder, the malicious user, takes the identity of some trusted user, and so basically it is an act of disguise. Spoofing can be applied to emails, phone calls, etc. Or in a more technical manner, computer spoofing can be done on IP address or DNS server, all those things. So basically, spoofing can be used to gain access to a target's, say, personal information, or it can spread malware through injected links or attachments. It can also be used to bypass some sort of network access controls, and it can be used to redistribute traffic, to conduct a denial of service attack. All those issues are there. So basically, it is the way of gaining access in order to carry out some major attack, such as man in the middle attack and all those things. The third one is disruption. Disruption means what? Some sort of modification again. And lastly, usurpation. So usurpation is a combination of all these things: modification, spoofing, delay, denial of service, DOS attacks, and all those things. So in any case of a security mechanism, we have to deal with these issues. Now coming to the policy and mechanisms. Policy means what? Policy are the rules which are being framed as a guiding mechanism to implement some sort of security in a particular system. So policy says what is and what is not allowed, and those rules are to be implemented using some sort of mechanisms. Mechanisms enforce the policies. Now, when the policies clash, discrepancies may create vulnerabilities. See here, basically, cloud computing or grid computing. Basically, these are examples of distributed computations. That means the source and the destination entities or nodes, they may be dispersed. They may be located at different places. They may be joined by some logical groupings, and all those things are there. Now, whenever it is some kind of distributed architecture being put into place, there should be definite mechanisms of access control issues. Those issues are there, and therefore, definite policies are to be maintained at a local level and also at a global level. Now, if there is some sort of clash happen somewhere, then discrepancies may result in some sort of vulnerabilities. That means during those times, miscreants or unauthorized users may try to gain access into those network architectures or infrastructures, and they may be, and the particular infrastructure may be compromised. Now, the policies can be defined in a hierarchical way also. Policies can be based on the role of the users. I already mentioned this earlier, that is role-based access control. Here, role means the particular operations which a particular user may be performing. Say, for example, user A is acting as a network administrator at a particular location. Now, if user A belongs to some logical grouping, some logical grid environment, that particular user may work in the role of a programmer. That means, based on its roles at two different places, his access rights can also differ. Basically, depending on the roles of the users, policies are to be framed to gain access to resources, all those things. Policies are made somewhat centralized, but implementation is distributed. As the architecture or the environment itself is distributed, so ultimately whatever policies we are forming, those needs to be implemented in the distributed fashion only. Now, the goals of security. What are the goals which we are trying to achieve when we are dealing with the security of a particular environment? So basically, there are three issues: prevention, detection, and recovery. Prevention means what? Prevent the attackers from violating the security policy. Detection means if there is some sort of violation occurs, then detect it as early as possible. And recovery means what? Stop the attack, assess and repair the damage, continue to function correctly, even if attack succeeds. So basically, these are three different types of schemas you can say which you can implement to deal with the security mechanism. Now, when we are implementing some sort of security mechanism, some operational issues are there. Number one is cost benefit analysis. Is it cheaper to prevent or recover? Now, I think in operating systems, we have studied the concept of deadlock prevention and deadlock avoidance. It is somewhat similar to that. Whether we should go for prevention or avoidance, whether we should go for prevention and avoidance or recovery mechanism. Let the security be breached. When it is breached, then only we will take necessary actions. Or let's implement some mechanism at the initial level to prevent or avoid any sort of security breaches. So those mechanisms need to be analyzed, and the costs which it will be incurring, that also needs to be taken care of. Number two is risk analysis. What about the infrastructure? That means, is it being used in some mission critical applications, say some sort of defense data or banking applications? Definitely, they will be needing a high level of security. Or in the opposite case, let's say an example that we can implement a lab setup for some academic purposes, which are not that much important. So in that case, risk analysis definitely is much less. And if a particular system is, and if a particular system needs high level of security, then in what level we are going to implement the security mechanisms in that particular environment. And third is law and customs. Are the desired security measures legal or not to enforce? Those also needs to be taken into consideration. Now, basically, attacks can be of two types. One is the one is the passive attack, and one is the active attack. Active attacks. So basically, passive attacks means obtaining some information that is being transmitted. Intruders are there; they will continuously watch for vulnerabilities in a particular message communication system. So there are two types. Number one is release of message contents. It may be desirable to prevent the opponent from learning the contents of the transmission. That means if someone tries to intrude into the environment, we have to prevent it from learning the contents of the transmission. That we should follow. We should implement it somehow. And second is traffic analysis. The opponent may not be able to uh, make out the actual content of the message, but it can try to analyze what sort of communication has been going on between the corresponding hosts. If the frequency and length of messages are very high, then it is some sort of say some sort of chatting may be going on. The opponent can make it out somehow. So so such issues are there. We have to mitigate those issues. It is very difficult to detect also. So passive attacks are difficult to detect, and we have to we have to minimize it as much as possible. That is the thing. Next is active attacks. So basically, active attacks involve some sort of modification of the data stream or the creation of a false stream. Now here there are four categories. One is masquerading. Masquerading means what? Taking the disguise of some other entity. One entity pretends to be a different entity altogether. That is called masquerading. Second point is replay. Replay means what? Passive capture of a data unit and its subsequent retransmission to produce an unauthorized effect. That means the actual data is being compromised here. It can be modified and subsequently it is retransmitted to the destination. That means the source or the sender has no information about the change of the data stream. Modification. What is modification? Modification is the alteration of legitimate message. Simple. And lastly, denial of service. Denial of service means the by some unauthorized means, unauthorized users, they are making the communication facilities unavailable to the concerned parties. That is called denial of service. So lastly, what are the services that security mechanism should enforce or try to enforce? One is confidentiality, that is the privacy or keeping the data private totally. Second is the concept of authentication. Authentication means what? Authentication means establishing identity of particular entity. Third is integrity. Integrity means the message should not be altered. It should be transmitted and it should reach the appropriate destination in the correct, unaltered manner. Fourth is non-repudiation. Non-repudiation means the order is final. That means if source A sends a message to destination D, then at some later time, source A cannot deny that no, I haven't sent that message. Those issues needs to be followed. And access control. Access control means what? Access control means stating the authorization rights of various users or resources. And lastly, availability. Availability means round the clock availability of the concerned resources to the end users or the customers. So with that, we will be concluding today's session. In the upcoming sessions, we will go into more detail on the security aspects which are being prevalent in the cloud computing.